Hi, welcome to my channel. In this video, I am going to explain about the support vector mission, decision function and predictions. So here, we are having the two types of data set. For example, linear data set and linear data set and non-linear data set. Okay, linear data set nothing but the data points that are separated by the help of linear equation, like plus points and positive points are there and some negative points are there, so these points are easily we can separate with the help of some line equation. Simply the type of data set is called a linear data set. So this is the positive points and these are called a negative points. These two points are separated with the help of a simple linear equation. So the type of thing is called as a linear support vector mission classification. Okay, and here one more thing is that is called a non-linear support vector mission classification. That means here, for example, the data points like positive points and positive points are there. Okay, and these are non-linear in the fashion. These are in the form of a non-linear fashion. Okay, so here our aim is we have to separate these positive points and negative points separately. So here is not linear equation is not possible to separate data into two parts. At that time, we are going to apply one model called as a non-linear model. Okay, so the type of model is called as a non-linear SVM classification. So this is in the form of a non-linear fashion. Okay, here applying some other technique. The technique is called as a non-linear support vector mission classification. So this model is called as a non-linear support vector mission classification. Okay, so like that we are going to predict the corresponding class level for the given data set using the linear SVM classification and non-linear classification. Here the decision function is very important in order to predict the corresponding class level. Okay, now we'll see in detail. So the decision function and the prediction of the SVM classification. So here the model is the linear SVM classifier model predict the class of a new instance of x. So the x is nothing but one instance that contains a number of features like x1, x2 and so on. xn, there are a number of features are there. But for these features we have to predict the corresponding class level with the help of support vector mission classification. Simply that model is called a linear support vector mission classifier. So by here applying some decision function, the decision function is very important here, not predict the corresponding class level. So the prediction is called the decision function is called y cap equal to w transpose x plus b, that is equal to w1 into x1 plus w2 into x2 plus and so on wn xn plus b. Our aim is we have to find the corresponding w value and corresponding w value and corresponding b value. That is very important here. Why? Because the x1 or x2 and xn are nothing but fixed values. Those are features of the corresponding data sets. Okay, so here we cannot change the values of x features of the corresponding instance. We can change the values of w1, w2 and wn and so on and b values. So based on the adjusting the values of w1, we can get the better results. So that is called a y cap value. So y cap gives the corresponding predicted value. Now, if the result is positive, the predicted class label y cap is the positive class. Otherwise, it is the negative class, that is it becomes 0. So here the linear SVM classifier prediction is based on the following equation, that is y cap equal to 0 if the w transpose x plus b is less than 0. If it is 1 if the w transpose x plus b is greater than or equal to 0. Now, so here we can see the two different type of figures are here. So one is when the dataset contains two features, that is petal width and petal length. Based on the petal length and petal width, you can classify the data into two parts. So simply here this is a model called as a linear support vector classification. Here we are having the different hyperparameters. One of the hyperparameters is c value. Okay, if the c value equal to 1, the margin is going to be very high between the two hyperparameters. Okay, this is hyperparameter 1 and this is hyperparameter 2, and this is the decision function that exactly divides the data into two parts. If the c equal to 100, the margin between these two hyperparameters is going to be very less. So, and less number of points are there here. Okay, so like that we can increase the margin and decrease the margin such a way that we can divide data into two parts. Okay, so simply this can be written in the form of one hyperplane. Okay, in the side figure, in the right side figure. Okay, here the corresponding model equal to H equal to, okay, that is y cap equal to W transpose X plus B value. That exactly divide the data into two parts here. Okay, so now it is a 2D plane, and because this data set has two features only, that is petal width and petal length only. Now the decision boundary is the set of points where the decision function is equal to 0. So what the meaning of decision function? The decision function is nothing but a corresponding value becomes y cap equal to y cap equal, that is W transpose X plus B equal to 0. Then that becomes the decision function. Now it is the intersection of the two planes, which is the straight line. Okay, that is represented in the form of a thick line. Okay, this is the straight line. This is called as your decision function. The decision function exactly divides the data into two parts. Okay, so now here this is the data points. So it contains petal length on one axis and petal width on the other axis. We are going to draw the plane, that is H equal to W transpose X plus B, that exactly divide the data into two planes. Okay, the above this is nothing but a 0, and so here the dashed lines are there. Okay, this is called H plus equal to, these are positive points, and H minus there, that is equal to negative points. Okay, so like that we are going to divide the data into two parts. Now the dashed lines represent the points where the decision function is equal to 1 or minus 1, that is plus or minus 1. Okay, they are parallel and at equal distance to the decision boundary. Okay, these are the dashed lines are there. These are hyperplane 1. Okay, hyperplane 1, and these are hyperplane 2. These are this simply is called as a H plus, and this is called as a H minus. These two are hyperplanes that are that value equal to 1 and this value equal to minus 1. These two lines are very parallel to each other. Okay, and also they are very parallel to each other, and also it is parallel to the decision function. Now if and also they form a margin around it. Okay, the training the linear SVM classifier means finding the value of W and B. Okay, our aim is y cap equal to W transpose X plus B. Our aim is you have to find out the values of W and B in such a way that we have to find out the best decision function. So making this margin as wide as possible, and while avoiding the margin violation, that is called as a hard margin classification, and limiting the margin. Okay, that is called as a soft margin classification. So like that we are going to construct that develop a model. That model exactly separate data into two parts. So simply this is called as our support vector transformation, decision function, and prediction of the corresponding class label with the help of support vector transformation. Okay, in the next video I am going to explain about the training the objective of the support vector transformation classification. Thank you for watching our video. If you like the video, please subscribe my channel. Thank you.